Hello guys, welcome to Placebo to Edu and my name is Vinay Kumar Nainpathani. Today we are going to see the analysis of resistors part 2. In this we are going to learn the parallel combination and the comparison between the series and parallel combinations. That too with simulations. So let's get started. See here, two resistors are connected in this manner, and here this is R1 and this is R2 and this is the voltage source V. For every resistor there will be a current which is passing through it, so it is represented as I1, and for R2 it is I2, and for V, like from the source, it is I. Okay, this is positive and this is negative. For source the current will come outside from the positive, right? Is that clear? And the voltages will be V1 for R1 and V2 for R2 and V for the voltage source. So what will be the relation between I1, I2, I and V1, V2, V? This is what we have to find. For this purpose, as usually, I am going to show you the simulations. So see here, this is the circuit which we are going to simulate. This is 1 kilo ohm resistance, this is 1 kilo ohm resistance, and this is 10 volts voltage source. Now if I start the simulation, you can see the yellow dots flowing in the circuit, that is current. So if you want to know what is current here, I'm going to show you the current here. It is 10 milliamps, and here it is 10 milliamps, and here it is 20 milliamps, and here it is 20 milliamps. Understood? So we have the currents which are flowing through the branches. We have 20 milliamps, 20 milliamps, 10 milliamps, 10 milliamps. So uh, I'm going to write all these in our circuit. So considering our circuit, here from the simulation we have R1 equals to 1 kilo ohm, R2 equals to 1 kilo ohm, and V is equals to 10 volts. Then we got here 10 milliamps and here 10 milliamps, and this is 20 milliamps and this is 20 milliamps. What we have to do is we have to find the KCL at this node. KCL should be calculated at nodes. So at this node we have one current entering into the node, that is I, and two currents passing out of the node, that is I1 and I2. So from KCL we have I is equals to I1 plus I2, right? So I have I is equals to, see here, I is equals to 20 milliamps. So I is equals to 20 milliamps, and I1 is nothing but this one. So I1 is 10 milliamps and I2 we don't know. Therefore I2 is nothing but 10 milliamps. Okay, so we have 10 milliamps here. Understood? This is how we use KCL to find the currents in certain branches. So we got all the currents in branches. So now we will see through the waveforms what will be the current in the lower 1k ohms resistor. Okay, so let me show you the voltage and current waveforms here. So see here, and here also I'm going to show you like this. I'm going to stop the simulation such that you can see what I am saying. See here, we have voltage is 10 and the current is 10 milliamps. Voltage is 10 volts and the current is 10 milliamps, and here voltage is 10 volts and current is 10 milliamps. I think you got clear idea what I'm saying. So here we have 10 volts and here it is 10 volts. and this is obviously 10 volts since it is a source. So the things I have, I will write here: V equals to 10 volts, V1 equals to 10 volts, V2 equals to 10 volts, and I is equals to 20 milliamps, I1 equals to 10 milliamps, and I2 is equals to 10 milliamps. This is for R1 is equals to 1 kilo ohm and R2 equals to 1 kilo ohm. What if I change R1 to 10 kilo ohms? Okay, what if I change R1 to 10 kilo ohms? Let us see that now. Okay, now I am changing R1 to 10 kilo ohms. Okay, here I am changing it to 10 kilo ohms, and now again I will run the simulation. Let's see what will happen. Yeah, see here, observe it carefully. We have a change in current. See here, current is changed from 10 milliamps to 1 milliamp in 10 k ohms resistor. So I'm writing all this on our question. Current in the 10 current in the 10 kilo ohms is I1. So it changed from 10 milliamps to 1 milliamp. Okay. And next thing, what is the current in 1 kilo ohm? The current in 1 kilo ohm is 10 milliamps. That is constant. It didn't change actually. So again, I'm writing all those things. Current in 1 kilo ohm is 10 milliamps, and current coming from the source is 11 milliamps. And the voltages are equals to 10 volts. V1 is equals to 10 volts, and V2 is equals to 10 volts. So we got a pattern to observe here. In parallel, voltage is same, and the currents are dividing. On what basis the currents are dividing? Let us discuss. So in parallel combination, voltage is same. Understand? This is a very important line you have to remember. In parallel combination of resistors, voltage is same, and the current is dividing. How the current is dividing? On what basis the current is dividing? Now I will explain you. Okay, so see here, this is I, this is I1, and this is I1, this is I2. We have already derived the relation between I1 and I2. This is the relation. So I'm writing the relation here. I is equals to I1 plus I2. We know that I equals to IR is our Ohm's law. So I is equals to V by R. So V by R equivalent is equals to I1 V by R1 plus I2 V by R2. Okay, then all these should be cancelled, and here we got R equivalent is equals to R1 R2 by R1 plus R2. So whenever R1 R2 are in parallel combination, we have the R equivalent, that is equivalent resistance should be calculated by using this formula. This one also should be noted down. This is very important result which you have to, which we will be using in our upcoming videos. Okay, next, V is equals to V1 is equals to V2. This is the condition we saw from the simulation, right? So taking only this one, V is equals to Vi, sorry, V is equals to V1, I'm taking this into consideration. V is equals to IR, right? I into R equivalent, right? And V1 is equals to I1 into R1, right? So I1 will be I into R equivalent by R1. Understood? And I derived what is R equivalent, that is I into R equivalent R1 R2 by R1 plus R2 whole divided by R1 cancel. Therefore, we have I1 is equals to R2 by R1 plus R2 into I, and similarly I2 will be R1 by R1 plus R2 into I. This is another result which everyone should learn and remember this result. Okay, so this is the basis on which the current is dividing. So current is purely depending upon the resistance. So in parallel combination, current will divide. Yes, current will divide based upon the values of resistors. That's what the conclusion. Okay, I have discussed both series and parallel combinations, right? So what will be the differences between what will be the difference between those two? I'm going to show you now. Okay, so first one, series and parallel. Okay, series. For series, R1, R2, right? And parallel, R1, R2, right? Okay. In series, everyone should observe that there will be one joint. That means one terminal of R1 will be connected with another terminal of R2. But in parallel combination, two joints will be there. So two terminals of both resistors should be combined. That's one point. So this is one terminal, and for this is two terminals. This is very important point. Whenever you see complex sums, we have to figure out which resistances are in parallel and which resistance are in series. For that, this rule will help us. And the next thing, in this, current in R1, R2 will be same. Okay, for this, voltage of R1, R2 will be same. Okay, understood? And here V1 is equals to R1 by R1 plus R2 V, and V2 is equals to R2 by R1 plus R2 into V. Here I1 is equals to R2 by R1 plus R2 into I, and I2 is equals to R1 by R1 plus R2 into V. Sorry, I. Okay. What you have to observe is we have Ohm's law. V is equals to IR, right? V is directly proportional to R, right? Basically, this is a proportional constant, but here V is directly proportional to R when I is constant, right? So V1 R1, since directly proportional, these will be like this. So V1 R1, that is V1 by R1 will be equal to V2 by R2. Since directly proportional, this should be the case which it should satisfy. Here I and R are inversely proportional. Therefore, here I1 is inversely proportional. So I1 into R1 is equals to I2 into R2. So this will be the condition we'll get from this one. Understood? So these are the differences between series and parallel, and we are going to do many sums in upcoming videos. Hope you guys enjoyed this video. So please like, share, comment and subscribe.
If you guys didn't like this video, please let me know through comments what are the developments to be done. Thank you.